This is SpaceTime, Series 25, Episode 57. Coming up on SpaceTime. Do black holes flip their poles? Surprising changes in Neptune's temperature. And NASA's SpaceX Crew 3 mission returns safely to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have just witnessed a rare and enigmatic event which may be the first evidence of a supermassive black hole flipping its poles and reversing polarity. Now, if correct, the new findings reported in the Astrophysical Journal provide a new understanding on the properties of these gigantic yet mysterious monsters that are thought to lurk in the heart of most, if not all, galaxies. Magnetic reversals are likely to be common events across the cosmos. Our Sun undergoes a magnetic pole reversal as part of its roughly 11-year-long solar cycle. The cycle sees geomagnetic activity such as sunspot numbers, solar flares, and coronal mass ejections gradually increase and get stronger until they finally reach a crescendo, at which point the Sun's magnetic poles literally flip polarity. It happens because the Sun is a massive ball of electrically charged gas called a plasma. As this plasma percolates, convects, and boils on its journey between the stellar core and the surface, it generates a magnetic field. And the geological record shows that Earth's magnetic field also flips, although unpredictably, averaging about once every 300,000 years. However, the last flip occurred some 780,000 years ago, so technically we're already well overdue for the next. But based on the growth of several strange magnetic features, such as the South Atlantic anomaly, that flip could be about to happen fairly soon, at least in geologic time. Now, what appears to be a similar event has now been observed on a supermassive black hole at the center of a distant galaxy. The galaxy is called 1ES 1927 plus 654, and it's located some 236 million light-years away. It was seen to dramatically become 100 times brighter in March 2018 before fading back to normal again. The alert was raised by the All-Sky Automated Survey for Supernovae. Now, it was originally thought that this eruption may have been caused by what's called a tidal disruption event. That happens when a star passes too close to a black hole and is ripped apart and destroyed. But now an alternative hypothesis, one which links the eruption's unusual characteristics to changes in the black hole's environment, possibly caused by a magnetic pole reversal, appears to have gained more support. Similar rapid changes in visible and ultraviolet light emissions have previously been seen in a few dozen galaxies similar to this one. But Subhashish Lahar from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says this marks the first time astronomers have seen X-rays dropping out completely while the other wavelengths actually brightened. The authors analyzed new and archival observations across the spectrum. NASA's Swift Space Telescope and ESA's XMM Newton Space Observatory provided ultraviolet and X-ray measurements. Visible light observations came from Italy's 3.6-meter Galileo National Telescope and the 10.4-meter Gran Telescopio Caneris Observatory, both located on La Palma in the Canary Islands. Radio measurements were required from the Very Long Baseline Array, a network of 10 radio telescopes across the United States, the Very Large Array Space Telescope in New Mexico, and the European Very Long Baseline Interferometry Network. Following the March 2018 detection, astronomers undertook a search of earlier detections by the NASA-funded Asteroid Terrestrial Impact Last Alert System. It showed that the eruption actually began months earlier, at the end of 2017. When Swift first examined this galaxy in May 2018, its ultraviolet emissions were elevated by 12 times, but they were steadily declining, indicating an earlier unobserved peak. Then in June, the galaxy's higher energy X-ray emissions disappeared. Now, when matter falls into a black hole, it first forms an accretion disk circling around the black hole's event horizon. The event horizon is a point of no return, beyond which gravity becomes so strong that nothing, not even light, can escape, and material passing this point falls forever into the black hole's singularity. While on the accretion disk, material is being crushed and stripped and ripped apart, releasing huge amounts of energy in the process. As the material on the accretion disk slowly swirls inwards, it gets hotter and hotter, emitting visible light, ultraviolet radiation, and then low-energy X-rays. And right near the black hole's event horizon, a cloud of extremely hot particles called a corona produces even higher energy X-rays. The brightness of these emissions depends on how much material streams towards the black hole. An earlier interpretation of the eruption suggested that it was triggered by a star that had passed too close to the black hole and was torn apart, disrupting the flow of gas. However, the new work suggests that such an event would in fact have faded out far more rapidly than what this outburst did. The unique disappearance of the X-ray emission provides the authors with an important clue. They suspect the black hole's magnetic field creates and sustains the corona. So, any magnetic change could impact its X-ray properties. That's why they believe a magnetic polarity reversal seems to best fit the observations. Now, according to this model, the field would initially weaken at the outskirts of the accretion disk, leading to greater heating and brightening in visible and ultraviolet light. As the flip progresses, the field becomes so weak it can no longer support the corona, and the X-ray emission vanishes. The magnetic field then gradually gains strength again, but in its new orientation. In October 2018, about 4 months after they disappeared, the X-rays came back, indicating the corona had been fully restored. And by the summer of 2021, the galaxy had completely returned to its pre-eruption state. This report by NASA TV.
At the end of 2017, a galaxy 236 million light-years away began a rare and dramatic transformation. It's an event astronomers are still puzzling over, one set off by changes near its central black hole. They first explained this as a tidal disruption event. That's when a star wanders so close to a supermassive black hole that it's torn apart. A new study of observations spanning the entire event suggests a different cause. The trigger may have been a flip in the magnetic field in the disk of material around the black hole. The Sun's magnetic field reverses polarity every 11 years. On longer timescales, even Earth's magnetic field flips. Starting in December 2017, the galaxy began to brighten in visible and ultraviolet light. The source of this brightening appeared to be the disk of material around the supermassive black hole at the galaxy's center. It peaked 3 months later at nearly 100 times its previous brightness. That's when regular monitoring with NASA's SWIFT satellite began. As the visible and UV brightened, X-rays from the galaxy dimmed. By August 2018, the higher energy X-rays had disappeared completely. A few months later, the high-energy X-rays came back, even brighter than before. They returned to normal within a year. These X-rays come from a cloud of super-hot particles near the black hole. It's a feature called the corona, which is formed by the strong magnetic field. The lack of higher-energy X-rays means that this structure was essentially gone. Based on observations from SWIFT, Europe's XMM satellite, and ground-based optical and radio telescopes, here's what may have happened. The visible and UV flare results when the flow of matter into the black hole increases. This may have started when the magnetic field in the disk's outer regions began to flip. The weakened magnetic field can no longer support the corona, which vanishes. The flipped magnetic field gains strength, restoring the X-ray corona, but the inward flow of matter is still high, so this emission is stronger than it was before the flare. Finally, the corona and disk return to their states before the flare, now with a flipped magnetic field. Rapid changes in UV and visible light have only been observed in a few dozen active galaxies like this one. But this is the first time X-rays have been seen to drop out as other wavelengths brighten. These surprising events offer a tantalizing glimpse at the extreme forces at work near an actively feeding supermassive black hole.
This is SpaceTime. Still to come, surprising changes in the temperature of the planet Neptune, and NASA's SpaceX Crew 3 mission returns safely to Earth. All that and more still to come on SpaceTime. Astronomers say they can't explain surprising temperature changes which have been observed in the atmosphere of the planet Neptune. The findings, reported in the Planetary Science Journal, were taken during a 17 Earth-year observation run tracking temperature changes on the distant ice giant. Neptune is the solar system's 8th and most distant planet, orbiting the Sun some 30 times further out than the Earth. It's 4 times the size of the Earth and has some 17 times the Earth's mass. Like its sister planet Uranus, Neptune has an atmosphere composed primarily of hydrogen and helium, along with traces of hydrocarbons and possibly nitrogen, as well as a high proportion of ices such as water, ammonia, and methane. But unlike the hazy, relatively featureless atmospheres of Uranus, Neptune's atmosphere has active and visible weather patterns, and the fastest winds in the solar system, reaching speeds as high as 2,100 kilometers an hour. However, the engine driving these fast winds remains a mystery. Astronomers used a series of ground-based telescopes, including the European Southern Observatory's Very Large Telescope, a VLT in Chile, to track Neptune's atmospheric temperatures over a 17 Earth-year period. What they found was surprising. There was a sudden drop in Neptune's global temperatures, followed by a dramatic warming at its south pole. The study's lead author, Michael Roman from the University of Leicestershire, says this change was totally unexpected. Roman and colleagues were observing Neptune during its early southern summer, and they expected temperatures to be slowly growing warmer, not colder. Like Earth, Neptune experiences seasons as it orbits the Sun. However, a season on Neptune lasts about 40 Earth years, with one Neptune year lasting 165 Earth years. In fact, it's been summertime in Neptune's southern hemisphere since 2005. And the authors were eager to see how temperatures would change following the southern hemisphere's summer solstice. Astronomers looked at nearly 100 thermal infrared images of Neptune captured over that 17-year period in order to piece together overall trends in the planet's temperature in greater detail. But they were surprised to find that despite the onset of the southern summer, most of the planet had gradually continued to cool over the past 2 decades. In fact, the globally average temperature of Neptune dropped by 8 degrees Celsius between 2003 and 2018. Roman and colleagues were then surprised to discover a dramatic warming of Neptune's south pole temperature during the last 2 years of their observations, when temperatures rapidly rose 11 degrees Celsius between 2018 and 2020. Although Neptune's warm polar vortex has been known about for many years, such a rapid polar warming has never previously been observed on the planet. The authors measured Neptune's temperature using thermal cameras that work by measuring the infrared light emitted from Neptune's stratosphere. For their analysis, the team combined all existing images of Neptune gathered over the last 2 decades by ground-based telescopes. This allowed them to build up a complete picture of Neptune's temperature and its variations during part of its southern summer. Because Neptune's roughly 4.5 billion kilometers away and it's very cold, the planet's average temperature is a chilly minus 220 degrees Celsius. Measuring its temperature from Earth required the VLT's imager and spectrometer for mid-infrared instruments. The authors also used data from NASA's Spitzer Space Telescope and images taken by the Gemini South Telescope in Chile, as well as the Subaru, Keck, and Gemini North telescopes in Hawaii. The unexpected temperature fluctuations could be due to changes in Neptune's stratospheric chemistry, or they could be due to random weather patterns, or even the Sun's solar cycle. So more observations will be needed over the coming years in order to better explore the reasons for these fluctuations. We'll keep you informed. This is SpaceTime. Still to come, NASA's SpaceX Crew 3 mission returns safely to Earth, and later in the science report, a new study suggests that espresso coffee affects men's cholesterol levels differently to that of women. All that and more still to come on SpaceTime. Four NASA SpaceX Crew 3 astronauts aboard the Dragon spacecraft Endurance have returned safely to Earth, splashing down in the Gulf of Mexico off the coast of Florida. The crew had just completed the agency's third long-duration commercial crew mission to the International Space Station, spending 177 days in orbit.
Dragon SpaceX, nominal trunk jettison.
Great news there. We clearly had successful claw separation, and the claw, again, those umbilicals that bring power and telemetry from the trunk and the solar cells to the Dragon capsule itself. So now Dragon is on battery power. We also heard the call to the crew that there was a successful trunk jettison.
That means that telemetry is looking good. The nitrox system is primed for cabin and suit cooling. Nitrox, of course, is that nitrogen-oxygen mixture that we pump through the cabin and the suits. It helps keep the astronauts nice and cool and comfortable while the exterior of their vehicle reaches 3,500 degrees. We want to make sure that the inside is nice and comfy for them. And nitrox, for those that might not be familiar, that is the same stuff that we use in scuba gear. So if you've ever been scuba diving, you yourself have also utilized nitrox. So up next, we have the final steps that Dragon will perform prior to reentry: the slew, or also known as maneuver, to deorbit burn attitude, and the deorbit burn itself.
And that's going to be a less than 8-minute burn, and looks like those thrusters are firing on those screens.
Dragon SpaceX, deorbit burn complete. Performance was nominal. Nose cone closure initiated.
Endurance copy is nominal burn, and we see the same thing with the nose cone closure in progress.
All right, good news. Deorbit burn is complete. That 7-minute, 45-second burn. They are committed to coming home.
Dragon SpaceX for entry briefing.
Endurance ready to copy entry.
Copy, Raja. At this time, I have no changes to timeline for you. Same anticipated blackout start and stop times as I briefed before. We are not tracking any vehicle issues at this time. And so far as weather goes, we are still looking great. There is a slight increase in wind speed at 7 knots from what I last reported, but we have calm seas and are ready to get you out of the water. How copy?
Copy, no timeline changes, so still expecting blackouts 4:30 and 4:37. No vehicle issues, and then little change in the winds from 3 to 7 knots, but still calm seas, and still go on the recovery team.
That's a good readback.
They're going from 17,500 miles per hour. That's their rough orbital velocity. The atmosphere will slow them down to about 350 miles per hour. That's when our drogue parachutes will deploy. At that point, they'll be at about 18,000 feet above the ocean surface. And then the drogue parachutes will continue to significantly slow the vehicle down. At the 6,000 feet altitude, the main parachutes will deploy. We've got 4 of those. Those are the super iconic orange and white parachutes that everybody loves to see. And what's really incredible is that the drogue parachutes do so much work during that initial phase between 18,000 feet and 6,000 feet that we don't. If we didn't have the drogue parachutes, those main parachutes would have to be much, much bigger in order to slow the vehicle down enough to make a soft landing. They're only going about 10, 15 miles per hour whenever they make contact with the ocean surface.
Nice. Complete with crew entry prep, visors are down.
Copy, Raja. Tablets secure, restraints are down, and visors are closed. Additionally, can you confirm that your satchel is fully zipped?
It is now.
Copy that. We are less than 4 minutes to anticipated LOS. We will talk to you on the other side at 4:37.
Sounds good. We'll talk to you then.
In just a few minutes until we have communications blackout, and we expect to hear from them again in about 10 minutes.
Yeah, they're going to experience about 3 to 5 Gs during this re-entry period. So if you've been on a roller coaster, you can imagine it's like that point where after you initially go up and that drop whenever you come back down, it's that feeling that they're going to have for a few minutes, I should say.
Dragon, SpaceX, comm check. Dragon, SpaceX, comm check.
Dragon has you, Endurance has you at per.
Great to hear from you.
So as you just heard, we had confirmation from Commander Raja Chari.
Dragon, SpaceX, expect automated chute deployment.
Endurance copy is expecting automated seat deployment for the sound GPS reacquisition.
We see the same. Expect deployment at standard altitude.
Endurance copy.
Dragon Endurance making its re-entry to planet Earth.
6 months in space. And this is the first time that these crew members have been in Earth's atmosphere in that time. As you just heard, we're standing by for drogue parachute deploy, so those 2 drogue chutes. The crew members will probably feel a little bit of a jolt as those deploy, but that's why they are strapped into their seats safely.
Dragon, SpaceX, brace for drogue window.
All right, looks like we have 2 healthy drogues there.
And then
Endurance is visual on 2 drones.
Copy, we see the same. Descent rate nominal.
There we can see the deployment of those main parachutes. The vehicle's velocity is about 119 miles per hour.
Yeah, SpaceX Dragon, we see 4 chutes, and we could distinctly feel the 2 disc rates. It looks like final descent rates.
And Raja, we see the same.
And teams are in position. They're moving their way closer to where the Dragon will splash down. Again, we'll have some fast boats that will approach the capsule first, ensure it's safe for the recovery ship to approach. And within an hour of these crew members splashing down on Earth, we expect to see them getting out of the capsule.
Copy 800.
The teams are about 3 nautical miles away from the splashdown site, so it's going to take them a little bit of time to get there in terms of the large vessel, but there is a fast boat, as we call it, that will be able to get to the capsule very, very quickly. Dragon Endurance carrying
Endurance, we copy, we see the same, and main attack.
Crew 3 crew has splashed down in the Gulf of Mexico off the coast of Florida. So right now, Dragon is
On behalf of the entire SpaceX team, welcome home. Willkommen auf der Erde. It's been an absolute honor to support you on your mission, Endurance crew, and thanks for flying SpaceX.
Thanks, Sarah. We're glad to be back. Thanks for letting us take Endurance on its shakedown cruise. Looking forward to watching many more flights of Endurance in the future. That was a great ride, and enjoyed working with the NASA and SpaceX team. Thanks for getting us to the space station and back safely.
Appreciate the words, Raja.
The Crew 3 mission launched on November the 10th last year on a Falcon 9 rocket, docking with the space station's Harmony module's forward port the following day. As well as taking part in more than 250 scientific experiments, the crew also conducted 3 spacewalks, performing space station maintenance and upgrades outside the orbiting outpost. Their works built on previous research investigating how fibers grow in microgravity. They used hydroponic and aeroponic techniques to grow plants without soil or growth medium. They captured images of their own retinas as part of investigation that could detect eye changes for astronauts in space automatically in the future. And they performed a demonstration of technology that provides measurements of biological indicators related to disease and infection. The astronauts also took hundreds of images of Earth as part of the Crew Earth Observation Investigation, one of the longest-running investigations aboard the space station, which helps track natural disasters and changes to the planet. The Dragon Endurance capsule will now be returned to Florida for inspection and processing at SpaceX's Dragon Lair, where teams will examine the spacecraft's data and performance throughout the flight. Crew 3's return to Earth came just days after the departure of the Axiom AX Crew 1 mission, also aboard a Dragon capsule, this one the Endeavour. It splashed down on the other side of Florida in the Atlantic Ocean. And just before they left, they witnessed the arrival of 4 more astronauts as part of NASA's SpaceX Crew 4 mission. It flew aboard a 3rd Dragon capsule named Freedom. A busy time indeed aboard the International Space Station. This is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.